Welcome to Elias Academy, day 71. Um, Today we're going to be looking at angles, just like this one, related to a circle. From the launch, those two questions, you've seen those. These are angles inside of the circle formed by a chord and a chord. And as we already studied and learned, that this angle is related to its intercepted arcs, the arcs it's pointing to, namely this blue arc, AC, and this red arc, DF. And we saw that when you sum the arcs and divide by 2, essentially the average of the arcs, you find that angle formed inside of the circle. And I'm going to use that terminology, inside of the circle. So you can see this is a 93-degree angle, and if I were to add my 2 arcs and divide by 2, it gives me that interior angle. No matter how I move this around, that relationship is still going to hold true. So let me put this back for a second. Undo. Today, what we're going to be looking at is what happens if that angle isn't inside of the circle. Is there any way I can force that angle outside? And it looks like, according to this, it doesn't want to go outside. And that's because if it goes outside, maybe this relationship of adding the arcs and dividing by 2, maybe that won't work. Maybe it won't happen. So let me hide this, and let me show you what it looks like when you get an angle outside of the circle. Notice my angle is outside of the circle now, okay? Outside of the circle. That's what we're focusing on today. We still have 2 arcs created, and this segment is like a chord, AD, but extended. And over here, this angle is formed by essentially 2 chords, but when we extend them to outside of the circle, that's called a secant. These are secants, and you have that on your first page of the notes. So if we just tried out our last lesson's relationship, the arc plus the arc divided by 2, that should give us the angle. Let's try that out. Let's see if we're correct. So I'm going to make a numerator. It's this arc plus this arc. And I'm going to divide by 2. And we can see 93 degrees and 29 degrees. No, that didn't work out. And if we show this interior angle again, you can see that interior angle is significantly bigger than that outside angle. So it makes sense that we shouldn't be able to get this outside angle by adding those 2 arcs. And one way you can think about it, this inside angle is like in between the 2 arcs. So it makes sense to combine and divide by 2. It's in between, right? It's including both of them. But this outside arc is kind of the other way. It breaks through that red arc. So it makes sense that we should do something other than adding. So let's get rid of this. All right, let's, how do I delete this? You know what, let me toss it off to the side. Okay, so it makes sense we should do something other than adding. And if we look at it, the angle's smaller. So instead of adding, maybe I should try subtracting. So let's see if that works. Let's make a number. Let's calculate. We're going to calculate our numerator, which is this big arc, right? That first arc, you can think of it as the big one. Notice how it's 122. It's bigger than that 64. And we're going to subtract this small arc, and we're going to take all of that and divide by 2. Okay, and let's see. Can I round that? No, it won't let me round. All right, let's see what we get. And let me pull that out, and let me change these properties. Let me round. Okay. So now if you look at, if we take this arc AC, the big one, and we subtract it, if we take the difference between these two arcs, the big one and the little one, and we divide by 2, we average it. Yeah, look, those numbers, those values are equal. So it turns out the way we're going to figure out this outside angle, to summarize, the angle outside of a circle, whenever you have that, it's going to come from taking the difference of the two arcs, and it's specifically the big arc minus the little one divided by 2. It's the average of the difference. So no matter how I move this, they all move together, right? No matter how I do that, this relationship holds true. Can make this bigger arc smaller, it still holds true. Let me pull this out. And this formula works with two secants, and it also works with what we call a tangent, right? If I made this, instead of a secant, if I made it just touch the circle at the top, it works that way as well, with a tangent and a secant. It should work, it should work when there's two tangents. Let me see if I can get this to do it. Boom. Yeah, and you see, now there's two tangents on the circle. And it's, oh no, go away. And it's saying this big arc, right, it's still the big one, 206, minus this little one divided by 2, that's going to give us our angle. So if you turn your attention to the board, the notes will be there for those 3 examples of 2 secants, a tangent and a secant, and 2 tangents. And then one way I like to remember this is the big-little theorem. You know, formally we have a name for it, but informally I like to call it that outside angle is going to equal the big arc, the biggie arc. Take away the little arc, you know. Big arc minus little arc. Hope you enjoy. Thanks.